Alright, so at this point you should have watched the other two videos that go over how the different rules of logarithms work and compare to the different rules of exponents. We are going to look at some examples now of how to use the expansion and combination principles that we've talked about. So if we want to expand something, here we have log base 3 9x to the 7th. And we want to expand it and make it into a sum or difference of logarithms. So we look for all of the different things that are multiplied together. Here we have a 9 and an x to the 7th that are multiplied together. So we are going to use the property that says when you have the product of two values, you can make it into the logarithm of a sum. So this becomes log base 3 of 9 plus log base 3 x to the 7th. A lot of times when we break things down like this, it allows us to simplify. Log base 3 9. 3 to what power gives us 9? 3 to the second power gives us 9. So this could be rewritten as 2. Over here, since we are expanding, we want to take the exponent and swing it down into the front. So this will be plus 7 log 3x. That is how expansion works. Log base 5 times the cube root of x to the 5th over 125 y to the 15th. So we need to break this down in several ways. The first thing that we need to consider is this cube root. All of the argument is under that cube root. It's usually a good idea, when I say usually I mean always, to think of your roots in terms of fractional exponents. So a cube root would be the same thing as 1/3 power. Now, one of our rules said that we can distribute an exponent through multiplication and division in much the same way you distribute addition and multiplication. So we take this 1/3, and when you take a power to a power, you multiply them. We take this 1/3 and we apply it to each one of the three pieces. So we will have log base 5 x to the 5/3 divided by 125 to the 1/3 y to the 15/3. Go ahead and reduce things. So that's just going to now be y to the 5th. Now we can expand this. This becomes log base 5 x to the 5/3. Now anything in the denominator is subtraction. So that's going to be minus log base 5 of 125 to the 1/3 minus, now again I'm still doing minus because this y to the 5th is also in the denominator. So that's going to be minus log base 5 y to the 5th. Now I can swing down my exponents, so that is 5/3 log 5x minus, now you can do this multiple ways. 125 is 5 to the 3rd, so the cube root of 125 is 5, and so that's going to be minus log 5 of 5, and then the last piece would be minus 5 log 5y. This log base 5, 5, that just cancels down to a 1. So in the end, we have 5/3 log base 5x minus 1 minus 5 log 5y. Fully expanded. So the other type of problem that we're going to see is combined problems. This is where you have multiple logarithms and you have to make them into a single logarithm. So let's say we had log 5 250 minus log 5 2. So when we combine those, what we are basically going to be using is our difference formula. So since we have the logarithms of differences, that becomes the logarithm of a single quotient. Log 5 250 divided by 2 gives us log base 5 250 divided by 2 is 125. And as we saw in a previous example, 5 to the third power is 125. So this quite simply equals 3. But by bringing things together, sometimes things will reduce down and become very simple. This type of thing also works when dealing with binomials or anything that you're taking a logarithm of. So we can do this problem in actually a couple of different ways. I'm going to show you two different ways to approach this. We could approach this by first looking at the negative, so and factoring the numerator. So the natural log, x squared minus 81, that becomes x plus 9 times x minus 9, and then that's going to be over x plus 9. Because subtraction becomes division, the x plus 9's cancel out, and that leaves us with a natural log of x minus 9. You could have also said this is the natural log of x plus 9 times x minus 9 minus the natural log of x plus 9. Now, since these two things are multiplied together, that would give us the natural log of x plus 9 plus the natural log of x minus 9 minus the natural log of x plus 9. We have a positive natural log of x plus 9 and a negative natural log of x plus 9, which leaves us the natural log of x minus 9. Again, combining, moving things around, trying to contract it and get it so that it is a single logarithm. So in this case, the first thing we're going to do is we're going to take the 3 and move it up to make it into an exponent. Now, one of the common mistakes, sorry, camera blurred out on me. Give me just a sec. One of the common mistakes students make here is not taking this number to the power. Remember, when we move that 3 up, it is going to affect the entire argument, not just the variable. So this becomes log 5 4x to the third plus log 5x to the fifth. So when we take the 3 to the fourth power, that is log base 5. 4 times 4 times 4 is 64x cubed plus log 5x to the fifth. We can now take the x cubed and the x to the fifth and combine those for a final answer of log base 5, 64x to the eighth. Those should help you out. On your lab tonight, you do not need to go past set 3. Do not do the exponential equations or the logarithmic equations. We will address that in our next class. Good luck and happy logarithming.